Welcome to Electronic Devices and Circuits Lab. So in the today's lab, we are going to make a circuit on multisim to conduct an experiment of half wave rectifier and full wave rectifier. So to make this circuit, first of all, we need to bring a certain components that will be used for making these circuits. The components that are required for making these circuits are your transformer, and we need two diodes when we fabricate a circuit for full wave rectification, and one resistor that will be able to control the current through the circuit. And we also need a particular AC power source and a ground. So let's bring these components into our model. So first we need to go to the component tab, and then we have to go to this particular groups. In this groups, we have to select the basics. Within the basics, you will find one transformer elements. Okay, so we have to select this transformers, and in this transformers you will find that lots of transformers are available, but we have to take a center tap transformer, as we know that in making a full wave rectifier circuit we need a center tap transformer. Basically we can also make a bridge rectifier, but in this particular experiment we are using the center tap transformer for making the full wave rectifier. So we have to select the center tapped transformer. So just you bring this particular component over model. Now we have to select a particular register. Okay, so you just see here we have the register, the same group basics. So we have to bring one particular register, and this component value can be changed later on as per our requirement. Now we have to bring the diodes into our model. So just you go to this particular group, and within the group we have to select the diodes. In the diodes, once you open this particular group, then you will find diode component is available at this particular tab. You go to this one, and then we have to select a particular diode. So for conducting this experiment, I am using 1N4001G. A model number of that particular diode is 1N4001G. So that diode is readily available in the laboratory. That's why I am choosing this particular diode. You can also choose any other diode, but you have to remember that before choosing any particular diode, you must have to go through its data sheet, and you should be aware about its data specifications. Okay, so we have to take this particular diode. Just you bring this diode into your model. As we have to make the full wave rectifier also, so we have to choose two diodes. So we have to take two diodes into our model. Now we have to select the AC power source. So you go to this and go to the sources, and then you select a power source. We have to take the AC power source. So this power source we have to bring it into your model. So now we have to also connect the ground. So just take the ground first. Okay. So now we have to bring this ground into our model, and now we can close this particular library. After making this one, now first of all, the first changes that we have to do is, first of all, we need to make a changes into this particular transformer. You just see in this transformer, we can see that it is a center tap transformer. In the primary side, there are total 10 number of turns, and the secondary side, you can see 5 plus 5. It is total number of turn is 10. So actually its ratio is 10 by 10, or you can say it is 1:1. So at present, this transformer is neither doing the step up operation, or neither it is doing the step down operation. Okay. So basically, when we are fabricating any circuit for rectification purpose, like half wave or full wave rectifier, because our AC supply mains is having a very high voltage, we need to step it down. So we have to convert this particular transformer to act as a step down transformer. So what we have to do is we have to make this turn ratio. We have to change this turn ratio. Okay. So to change this turn ratio, just you try to double click on this, and then you just make it 40. Okay. I am taking the ratio as 4:1. Okay. So whatever be the input voltage here, it will be divided by a factor of 4 towards your secondary side. Okay. So you just make it 40. So it will become 40/10. Fine. So the transformer turn ratio is now, it is 4:1. So now it is acting like a step down. Now you can connect the circuit. So just to make the circuit connection, so you connect this positive side to this particular point. Now you can connect this side to this side, and then you have to connect the ground. Okay, so we need to connect a ground. So you have to connect the ground to this particular point. Now, first of all, we need to make the half wave rectifier circuit, and later on we can make the circuit for full wave rectification. So making the half wave rectifier, as we know that we need one diode and one resistor. So we have this resistor, so just bring this resistor here. You can make the connection. Okay, so we have to connect this point to this particular point, and then we have to connect this particular side to one of the diode terminal. So this should be connected here. Now you remember that when we are making any circuit like full wave rectifier or half wave rectifier, we have to also make certain observation. For example, we have to look at the waveform across this particular load. Okay, across this particular load, we have to make the we have to see the waveform of rectified signal, and again we have to also measure certain parameters like what is VRMS, what is IDC current or VDC voltage through this across this particular load, and what is the ripple factor of the circuit. Okay, so do this particular measurement. So what we need to have is we need to also measure what is the current passing through this particular load resistor. So to do that, what we have to do is we have to connect one multimeter. Okay, so first you try to bring the multimeter into the circuit. So you just go to the right panel, and the first element is our first apparatus is our multimeter. Okay, so you just bring it into your model. Now we have to make the connection. Okay, so that this multimeter should be able to measure the current. You know that the multimeter should be connected in series. So this should be connected to this particular terminal, and the other terminal should be connected to your the terminal of your resistance. Now you can see this is right now it is selected as a voltage. So we have to measure the current. So you just select the current value. Okay, so it will be directly measuring your current. So now again we have to see the waveform across this particular resistor. So we have to also bring the oscilloscope into our model. So go to the right panel, you can see multimeter, you can see function generator, wattmeter, and this is our oscilloscope. So we have to bring the two channel oscilloscope into our model. So now this particular point will be connected to one side, and the other side should be connected to your this point. Okay, and this way we will be able to measure our particular voltage across voltage waveform across our resistor. So now just to have the limited current through the circuit, I'm just making this resistance value equals to 10 kilo ohm. That will be sufficient so that the current should be limited. You must be aware that this all diodes are having its own current carrying capacity, and accordingly we have to choose the resistances. Fine. So this way we can make our circuit. Okay, you can also connect this point to the ground. Okay, no issues. You can just copy it and just paste it over here. Okay, no issues. You can paste, then you can make this connection over here. Okay, so after having this circuit, okay, now we have to start the simulation. Okay, right now the second diode is not connected in the circuit because we have to make the half wave rectifier. Now just you try to see this, we have to first simulate this circuit to get the waveform and get this particular values. Okay, so if you start the simulation, okay, now the simulation is already started. Okay, so we can see this. Now we can see the waveform over here. Okay, we can see the waveform over here. So what waveform is coming now, you can see here. Okay, so first of all, you see it is 5 volt. Okay, at present it is 5 volts. So just to make it a little large. Okay, so now I have made it 20 volt. Okay, 20 volt per division. So you have to particularly select this particular sensitivity. Accordingly, you have to select the sensitivity so that you will be able to measure this particular voltage. Accordingly, you have to also select your this particular time sensitivity. Okay, so this waveform is now, because it is at 60 hertz, it is varying very fastly. Okay, so what we have to do is we have to first stop it, and then we can see the waveform. Fine. So what we have to do, just you go here and you just stop it. Okay, so once you stop it, you can see this, because it is a half wave rectifier. Okay, this type of waveform you are going to get. Okay, you can see for this positive half cycle, okay, we are going to get a certain output, and for the negative half cycle there is no output. Okay, so this is our half wave rectifier output. Okay, so Now, in this particular half wave rectifier circuit, what we have to do is we have to measure certain parameters. So first parameter that we want to measure is what is the V maximum value, okay, of the output. Okay, so whatever with the input we have given, you can see 120 volt VRMS we have given, and 60 hertz signal it has been applied. Fine. Now you can later on you can just verify it, because it is having ratio 4:1. So you can verify what is the maximum voltage that may come across this two terminal. Okay, because whatever it is, if it is 120 volt VRMS, then it should be divided by a 4. So 30 volt VRMS may come across this two terminal. So after having this circuit, now what we have to do, we have to measure the what is the V maximum. Fine. So just you bring this pointer over here, okay, at the maximum point, and here you can observe the changes in the values. Okay, so what value we are getting, almost you can see we are getting this value almost equals to 41.628 or 641.657. Okay, so the maximum value is around 41.658. Okay, the maximum value, so V maximum is equals to 41.658. that is our value. So now we can just uh, note down this value into our Excel sheet. So go to your Excel sheet, and then we have to note down this particular value of V maximum. See, for the half wave rectifier we have several equations. Fine. So what are the equations that we have is, we are having the VRMS equation equals to Vm upon 2, VDC equals to Vm upon pi, and similarly you can get the IRMS value, and you can have the IDC values. So these are the different formulas you can get in any books. Now what we are writing is what is the V maximum. Okay, so what value we have got in the V maximum, we have got as 41.658. So you can note down this value over here. It is 41.658 volts. So it is 658 volts. So okay, so we have to keep this value 41.658. Now we have to also write the IDC. What is the DC current that is flowing, and that should be written in the milliamperes. Okay, so you just go to your model. You can see this DC current we are measuring. Okay, we are measuring the DC current through this particular load, and that value is equals to 1.324 milliamperes. Okay, so just you note it down. Okay, you have to note it down, these values, 1.324 milliamperes. 1.324 milliamperes. So now after writing this value, I have already using a formula to calculate all other rest of the values. Okay, so now you can see, as we know that we have to measure the VRMS value, we have to also measure the IRMS value. So basically when we are using multisim, okay, this particular multimeter will not be able to give you right results of VRMS and the IRMS. Okay, if you bring the multimeter and if you go for measuring the AC components, okay, that AC component will not be correct, because it is not a pure sinusoidal wave. Okay, it is a half wave rectified output. So just we are getting a half wave rectified output. It is not a pure sinusoidal wave, and therefore it is not going to give you the right result. So basically only this two quantity we have to calculate, the calculate that I have tabulated in the Excel sheet. Okay, so after doing this, okay, we have to calculate the VRMS by following the formula. Okay, so I have used these formulas. You can also note down these formulas, and you can directly apply the formula in the Excel sheet to get this particular equations. So once you will get the VRMS, and you similarly you can calculate the IRMS values, okay, by following these formulas. Okay, as you know that our VRMS is nothing but Vm upon 2. Okay, so this is how I have calculated. I have calculated Vm upon 2. Okay, and IRMS is equals to Im upon 2. Or you can also say, if we want to calculate the IRMS, we can calculate IRMS by dividing the VRMS by a factor of resistance. It is 10 kilo ohms. Fine. So you can calculate the current in milliampere. So you just divide it by 10, so that you will be getting the value in kilo in milliamperes. Fine. So that way we can calculate the IRMS current. Okay. So that just dividing the resistance, dividing it by the resistance, you will be able to get this particular value. Fine. So this way I have calculated the VRMS and the IRMS. And then after this, we have to calculate the ripple factor. So we know that the ripple factor is actually defined by this particular equation, RMS value of AC component divided by the DC value of the wave. And later on, you will find this particular equation for the ripple factor is root over 1 upon RMS divided by RDC IDC whole square minus 1. So by using the formulas, I have calculated these values. Okay. And this particular ratio, I have set it as equals to X, and then I have calculated the X square, and then I have calculated this square root value. Okay. And that is our equals to ripple factor. As you know that the ripple factor for the half wave rectifier is about a 1 point. It is a means theoretical value you must have seen in the various books. It is 1.21. Okay, so we are getting this value is equals to 1.214462. Okay, so this is what we have to get from the formula. Now as we have done our experiment for half wave rectification, similarly you can again perform the experiment for the full wave rectifier. So in the full wave rectifier, you remember again we have to do the similar experiment. Okay, just to stop it. Okay, just to stop it, and now you have to modify the circuit. Okay, so how to modify the circuit? Just you make a reconnection, just delete this all connections. Okay, just delete this all connections, and now this resistance has to be connected from the center tap point. So just to bring it up a little bit. Okay, yes. Now you can have to connect this from this point, and then this should be there in the model. Okay, and you remember that this current whatever current that we want to measure, this current should be a current through the load. Okay, remember that. So if you connecting this point to this point, okay, you make this connection properly, and after that you have to remember that this should be measuring the current through the load. Okay, so if we want to do that, what we have to do is just to remove this connection again. Okay, just to remove this connection and just reconnecting it. So how to connect, you please look at it carefully. Okay, so first I am doing this connections. So what we have to do is just to connect these two diodes. Okay, just to connect two diodes, and then you can connect this one. Okay, you can connect the positive side to this side and the negative side to this side, because we know that the current will be flowing from here to here in this direction. Okay, so that should be connected like this. We have to connect this one to this point, and then they should be connected to this point. Okay, so this way we have made our connection. Our connection is now completed. Now again we have to connect our oscilloscope. Okay, so this positive point should be connected to this resistor. Okay, one of the point of the resistor like this, and the other point should be connected to this other point. Okay, this way. So now we have made our connection. Now what we have to do is again we have to simulate our circuit, and then we have to observe the waveform. So once you simulate this particular circuit, this type of waveform will appear. Just you pause it. Okay, and then you can see we are getting a full wave rectified output. Okay, we are getting a full wave rectified output. You can just make it like voltage sensitivity, you can change a little bit so that you can do the proper measurement. Okay, you can change this time sensitivity a little bit, and then you can get this rectified output. Okay, so now you can see what is this DC current, and you can measure the what is the V maximum value. So again you can measure the V maximum value. Okay, so you must be getting this value somewhere around 20.546 or 20.581. So I hope this is the maximum value, 20.581. Okay, so almost 20.581 is our maximum value. Okay, 581. So okay, 588. So now you can just go to your Excel sheet and just make this value, just note down this value 20.588. Okay, this is our voltage 588. Now we have to write down the DC value. Okay, so what is our DC value here? IDC value. So go to your circuit. So this value is measuring as 1.298 milliamperes. So just note it down, 1.298 milliamperes, 1.298 milliamperes. Fine. So after doing this, again, this will be calculated automatically as per the formula. And then you can see that after doing this calculations, we are having this different equations. You can verify all these results. A little bit variation you may find, but you are getting the ripple factor is equals to 0.50787 as per our results, whatever we are getting in this particular circuit. You know that the ripple factor for your full wave rectifier in the case of center tapped full wave rectifier is about 0.482. Okay, so we are almost getting the same result. Okay, we are almost getting the same result. So you can try this particular circuit. You just try your own. You just try to bring this particular components onto multisim, and then you try to make this circuit and do the measurement. I hope this circuit you must have enjoyed. You can do it yourself and try to verify the circuit. So thank you for watching.